Okay, Cartesian equations of a line. Okay, so we've given you another form. The last lesson we talked about, we had parametric form and we had vector forms of the equation. This is a third form of the equation called the Cartesian form. Okay, the Cartesian equations of a line in R2, again we're talking about just two-dimensional space, is this equation here. Some coefficient of x, coefficient of y, constant c is equal to 0. This is Cartesian form, where vector n, okay, the two coordinates of n are actually our values of a and our values of b, and is a normal to the line. Okay, now this is important. A normal to the line is a vector drawn from the origin, perpendicular to the given line to the point AB. So this is a vector from the origin that's perpendicular to our line. So let's say we have some line going on our Cartesian plane like this. Here's our plane. I'll do my best to try to make this parallel. Sorry, perpendicular. If this is our line, let's say, our perpendicular line or our normal to this line, does that look perpendicular? Yeah, looks good. Would be perpendicular to that. Okay? So this blue line here would represent our normal vector, where our red line is our vector in general. Okay? So that's what they mean by a normal. A normal will help us find our Cartesian equation or the form of it. So we're going to jump to example number 1. It's on page 436, and again, this is lesson 8.2. Okay? Let's jump over here. Example 1. Determine the equivalent vector and parametric equation of the line, and the line is given as y is equal to 3 over 4x plus 2. Okay? So, I want you guys to remember, this is from way back in grade 9, this is an equation of a line. An equation of a line is usually written as y is equal to mx plus b. We'll write those in different letters. Here's our m, and here's our b. Okay? This would stand for our b, and this stands for m. B is the y-intercept when we're talking about an equation of a line. So our b would be where we cross, which would be at this point, let's call it 1 and 0. That's wrong. 0 and 1. Okay? That would be our... Oh, sorry. You know what? Let's use 2 because the number is 2. Thank you. So let's say it's the number 2, 0 and 2. And its slope is 3 over 4, which is also known as the rise over the run. So we'd say we'd go up 1, 2, 3 over 1, 2, 3, 4. There's our next point. Okay? That's the idea. Now we've got to relate this back to our vector form. So if you guys remember our vector form, our vector is equal to vector r0 plus t and directional vector m. Directional vectors relate to maybe what part of a normal linear equation? Anyone know? What would this m be related to in our linear form? Slope. Yeah, and they essentially end up using the same letter so that you guys can make that connection. Okay? Our slope and our directional vector m have the same idea to them. The directional vector tells us how or where we're going to go, and that's essentially what slope does too. It tells us how much we move from one point to another. So, in order to find the directional vector, okay, we know the directional vector is going to be from the origin, and it's going to represent slope, okay? Because whatever points that is at, that will be our slope. So, if our rise over run for our linear line is 3 over 4, okay, and we're talking about a directional vector, if our rise deals with the y and our run deals with our x, our directional vector will be simply just plugging these values into our x and y values. So our directional vector is 4 and 3, and it makes perfect sense. We go over 1, 2, 3, 4, and up 1, 2, 3. So I'll try to draw this parallel to that. That would represent our directional vector m. Okay. So we have our m part of the equation taken care of. Our r0 stands for just a point on the line. Okay. plus t 4 over 3. Okay. Remember, t is any scalar or parameter. R naught. Do you guys know any points along this line? 0, 2. Simple as that. So our vector form, 0, 2 plus t 4 and 3. That would be our vector form. Now, parametric form. We're going to go from our vector form in this one to parametric, and all we're going to do is, instead of writing it as vector r, we're going to write it as its component values x and y is equal to, again, 0, 2 plus t 4 and 3. And remember, I'm just going to highlight what essentially will go together. We're going to have x 0 and t4. Okay, we'll underline it. And we're going to have y 2 and t3. Okay, t gets used in both of the parametric equations. So x is equal to 0 plus 4t. X is equal to 4t. And y is equal to 2 plus 3t. And there's our parametric forms of the equation. Put it all together. Example 2 actually gives us a parametric form of an equation. So let's just keep going with this. It's the same idea. The only difference is if they've given us our our equation of a line in vector form. So our vector r is equal to 3, negative 6, plus, and instead of using t, they're using the variable s, negative 1 and 4. Okay, where s is all real numbers. So they want this in the slope y-intercept form, which is essentially what we talked about just a second ago, y equals mx plus b. Okay? So we have to take this form above and put it into our y equals mx plus b. Well, we know that our directional vector m is essentially going to be our slope. If this is our x value and this is our this is our y value, our slope m in this case, well, I guess we'll do it in green here. Our slope m will be the y value of this 4 over the x value, negative 1. In other words, just the negative 4 as a number. So y is equal to negative 4 x plus b. Now the difference here is, do we have the y-intercept in this question? What is this point? It's just a point. It's just some point along the line. It's not the y-intercept. But we can use that in order to find our y-intercept. Because this point does represent any x and y value, we're going to plug those in for the x and y values here. So our y value is negative 6 is equal to negative 4 times x is 3 plus b. Okay. Negative 6 plus 12 equals b. So I did 4 times 3 is negative 12, brought it over, plus 12. 6 equals b. Our y-intercept form will be y is equal to negative 4x plus 6.